So here we are, James's dad cooking. He's actually a very good cook. Let's see how long James has to wait for his dinner. So the first part of the question is asking whether the use of a histogram is justified. Well, some people think that a histogram is only necessary when we've got varying class widths, and all these class widths are the same. But it's not that really that decides whether we need a histogram or not. It's a question of whether the data is continuous or not. So a histogram is justified because the data is continuous. So the next question is finding estimates for the mean and standard deviation. Nowadays, you would be expected to put that into your calculator. You need to use the midpoints 25, 23, 25, 27, 29 and 31. Pop that into your calculator and you should get figures of 27.3 and 2.3 minutes. So now we've got to find an estimate for the median time taken. So how are we going to do that? Well, firstly, we need to know what position the median is in. There are 365 data points, so the position of the median is 183. Now, there's various different ways of, well, at least two, maybe three different ways I can think of finding an estimate for the median. The way that I like to do this is use the cumulative frequency. So I'm imagining the cumulative frequency chart, and I'm just looking at the part of that which is the part where the median is. But where is the median? Well, if it's in position 183, then it must be somewhere in this class here, the 26 to 28 class. So I'm thinking about 26 to 28. So when I zoom in on that particular class on its own, I'm just looking at the 26 here to 28 there, and these figures are the cumulative frequencies. So 103 is those two numbers added together, 229 is those three numbers added together there. So that's the cumulative frequency chart, and the median is somewhere between these two numbers at position 183, or at least the median position is at 183. So the median itself would be here. So what I'm going to do now is put some more of the numbers on this this little chart. I'm going to call this gap here in red X, and the figures on the vertical sides of these two triangles are 80 and 126. This 126 incidentally is the same as that number there. So now I've got two triangles which are similar, so I can use similar triangle rules to write down this little equation here, and when I solve that equation I find the value of X is 1.27. So the median then is going to be this 26 here plus X. So the median is 27.27, or 27.3 minutes rounded to two significant figures. That's an estimate of the median. And finally, this last part of the question, would the mean or the median be a better average? Well, the mean and the median are, to one decimal place at least, the same. They're very similar numbers, and that indicates that the distribution is roughly symmetrical, and in that case the mean is the better average to use because it uses all of the data points. So I hope you got the same conclusion as I did, and that you may or may not have used the same method as I did, but that's the method that I tend to use.